Hello and welcome to this channel. In this video, we are going to look at circle theorems. So I encourage you to watch the video until the end because I will be explaining and revealing the deep secrets on how to answer questions, exam questions about circle theorems. Okay, so before we go ahead and answer exam questions on circle theorems, first of all, I want us to look at the general angle rules. Then from the general angle rules, we will now look at angle theorems. Then from the general angle rules, we'll look at circle theorems. Number one, you need to know that the sum of angles in a triangle add up to 180. So the sum of angles of any triangle add up to 180. For example, if you have an angle here, x, you have another angle here, y, and another angle here, z. When you add these angles, you should have 180. So what it means is x plus y plus z, you should get 180 degrees. Okay. The next property that you are going to look at on the general angle rules is angles on a straight line add up to 180. So this is a straight line and the sum of angles here on the straight line is 180 degrees. So this is 180 degrees. Okay, the other property that you are supposed to remember and look at is this one. The sum of angles in a cyclic quadrilateral add up to 360. So if you have angles A, B, C, D, so this thing here, this shape here, which is inside the circle, is a quadrilateral. This shape here, a quadrilateral is a four-sided shape. So if a quadrilateral is inscribed or is inside the circle, then the sum of all the angles should add up to 360. The sum of angles in the cyclic quadrilateral should add up to 360. So what it means here is that when you add this angle A plus angle B plus angle C plus angle D, you should get 360 degrees. And next, we're going to look at a chord. A chord is a line that connects one part of the circumference of the circle to another. So you can have many chords. So even this one is a chord. Even the diameter is a chord as long as it is connecting one part of the circumference of a circle to another. Okay, that is also very important. Next, so please, I encourage you to watch the video until the end as I reveal the secrets on how to answer questions, exam questions on circle theorems, because I'll be revealing the deep secrets. Okay, so number 6, we need to know that when this line is coming from the center to the circumference, it's called a radius. Okay, a line that comes from the center of the circle to the circumference of the circle is called the radius. Okay, so you need to know that the angle between the radius and the tangent, the angle between the radius and the tangent of a circle to the circle is equal to 90 degrees. So the radius meets the tangent at 90 degrees. Okay. Now that we've looked at the general angle properties, we'll now go direct and look at the circle theorems. And these theorems are going to help you answer questions, exam questions. Okay, so watch the video until the end as I reveal the deep secrets of how to answer exam questions on circle theorems. Okay, so the theorem number 1 says the angle at the center is twice the angle at the circumference. So the center is this one here. Let's say this is O, center O. So the angle that is here at the center should be twice the angle at the circumference. So if this is 60 degrees, so this angle should be twice the angle at the circumference. So if this is 60 degrees, to find the angle on the circumference, you divide this 60 by 2. So it will be, this on the circumference will be 30 degrees. The angle on the circumference will be 30 degrees. And the next property we are looking at is the angle in a semicircle is 90 degrees. If you have the diameter, okay, the diameter and an angle being formed here, okay, so this angle that has been formed here is 90 degrees, provided that this is the diameter. So this diameter is cutting the circle into 2 parts, equal parts. So any angle that is formed in the semicircle is 90 degrees. The next theorem we are looking at is angles formed from the same segment are equal. When you look at this, this is a segment, and within this segment, okay, so this is a segment, and within this segment, this angle here has been formed. This angle here has been formed. But again, from this same segment, another angle has been formed. This one. This one. Again, from the same segment, another angle has been formed, which is this one. Again, from the same segment, another angle has been formed, which is this one. So all these angles have been formed from this segment. And so because these angles, all these angles have been formed from this segment, this angle and that angle and that angle and that angle is equal. So all these angles is just one angle. So if this is 20 degrees, it means even this one is 20 degrees, even this one is 20 degrees, even this one is 20 degrees. The next property that we are looking at is opposite angles in a cyclic quadrilateral add up to 180. So if you have an angle A, B, C, D, the opposite angles add up to 180, meaning if you add A and B plus D, so B plus D, you should get 180 degrees. Again, if you add A and C, A plus C, you should get 180 degrees. The last property, the last theorem that we are going to look at is this one. The angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. So here, what it means here is that if you have a tangent, this is a tangent, if you have a tangent, and inside a chord is meeting this tangent and another chord is meeting this tangent, forming a triangle, then this angle here is equal to this angle. Then this angle here is equal to this angle. So meaning if this is 65 degrees, then even this one will be 65 degrees. If this is 30 degrees, okay, so if this is 60 degrees, even this opposite, the angle that is opposite to this, which is this one, should also be 60 degrees. Okay, so here is an exam question. In the diagram, A, B, C, and D are points on the circumference center O. So O here is the center of this circle. Then angle BAD is 55 degrees. Angle BAD is 55 degrees. Angle BOD is equal to x degrees. Angle BOD is equal to x degrees. Then angle BCD is equal to y degrees. BCD is equal to y degrees. The first question says, work out the value of x. Work out the value of x. So we are being asked to find the value of x. Now, when you look at this x, what circle theorem are you going to use in order for you to find the value of x? We're going to use this theorem here. The theorem that says the angle at the center is twice the angle at the circumference. This angle here at the center is twice the angle at the circumference. Okay, so that's the theorem that we're going to use. So since at the circumference we've been given 55 degrees and they want us to find the angle at the center. So for us to find the angle at the center, we need to multiply this 55 by 2. So we're going to say x is equal to 55 degrees times 2, which gives 110 degrees. So x is equal to 110 degrees. Give a reason for your answer. So the reason is angle at the circumference. Angle at the circumference is half the angle. Okay, is half the angle at the center. So that's a reason. Or in other words, you can say the angle at the center is twice the angle at the circumference. It's the same reason. But B, work out the value of y. Now again, you ask yourself, which property or which theorem are you going to use in order for you to find the value of y? You're going to use this property here that says opposite angles in a cyclic quadrilateral add up to 180. Yeah, so when you look at, so this shape that is inside, that is been highlighted in red, is a quadrilateral. A quadrilateral is a four-sided figure. So we are going to use that property that says the opposite angles of a cyclic quadrilateral add up to 180. This quadrilateral is cyclic because it's inscribed or it's inside the circle. So we're going to use that property that says opposite angles of a cyclic quadrilateral add up to 180. So for us to find y, we are going to subtract 55 from 180. So here we are saying y is equal to 180 degrees minus the angle that is opposite to this angle, which is 55. Okay, so minus 55 degrees, and this gives 125 degrees. Give a reason for your answer. The reason is opposite angles of a cyclic quadrilateral add up to 180. So that's what we are going to say. So we say opposite angles of a cyclic quadrilateral add up to 180 degrees. So that's a reason. Okay, here is another question. In the diagram below, points A, B, C, and D are on the circle. BD is the diameter. So BD is the diameter of the circle. Then angle ACB is 42 degrees. Angle ACB is 42 degrees. And angle CAD is 33 degrees. And the lines AC and BD intersect at x. Okay, so this is the intersection where here. Find angle CBD. Angle CBD. So the vertex, the middle letter, indicates the vertex where the angle is lying. So when they say CBD, so the angle they are talking about is this one here. So they want us to find this angle here. Okay. Now, what property or what theorem are you going to use in order for you to find angle CBD? We will use this theorem here that says angles formed from the same segment are equal. Okay, angles formed from the same segment are equal. So when you look at this, this is a segment. Okay, and this segment has formed this angle 33 degrees, and so the same segment has also formed another angle this side, which is the angle that we are looking for, this one. So because this angle and this angle are being formed from the same segment, it means that angle CBD also will be 33 degrees. Okay, because they are being formed from the same segment as this angle here. So angle CBD is 33 degrees. The next one, they want us to find angle ACD. Angle ACD. So the angle they are looking for is this one here. But remember, they said this is a diameter. So what property are we going to use in order for us to find this angle here? What property are we going to use? We'll use this property here that says the angle in a semicircle is 90 degrees. So because they have mentioned to say BD, which is this one, BD is a diameter, it means the angle that is formed here, the total angle here is 90. The total angle here is 90. Here, it's 90. But out of 90, we have 42 degrees. So how are we going to find angle ACD? So angle ACD will be equal to 90, which is the entire angle here. This is the entire angle, the 90 degrees minus the one that we've been given already, 42 degrees, which gives 48 degrees. So angle ACD is 48 because the entire is 90, because this is a radius, this is a diameter. Okay. We look at the last one. Angle AXB. So they want us to find this angle here, the one that is at X. Okay, so we can also, we can first find this angle here in order for us to find the angle AX. So we can find this angle and this angle, then we'll use the property of angles in a triangle to solve for X. So since they have said this is a diameter, it means the angle that has been formed here, the entire angle is 90. Okay, is 90. So this also entire angle is 90. But out of 90, we have 33 degrees. So meaning we're going to say 90 minus 33 degrees. It will give us here 57 degrees. So here 57 degrees, because the entire angle is 90, but out of 90 we have 33 degrees. So 90 minus 33, we have 57. This one being a diameter. And then we need to find this angle here. This angle here, we are going to consider this segment here. This segment has formed this angle here, and this angle, which is ACB, we found is 48. So this is 48. We found already that it's 48 CB. So this segment has formed this angle here, which is 48, and the same segment has also formed the angle here. So angles formed from the same segment are the same. So if this is 48, even this one will be 48 degrees. Okay, so this segment has formed this angle, and the same segment has formed this angle. So meaning they are equal. So this is 48. So now for us to find x, the angle at x, we will now add this plus this plus this. We'll use now the property of the sum of angles in a triangle, that is 180. So when we add this and that and this, we should get 180 degrees. So we are saying 57 plus 48 degrees, or these are degrees, plus, we'll just say x, angle x, you should get 180 degrees. Reason, angles in a triangle, because you are forming, this is a triangle that has been formed here. Sum of angles in a triangle add up to 180. So when you add 57 plus 48, you have 105 degrees plus x is equal to 180 degrees. So you want to remain with x alone, this side on the left hand side, because it's the one you're looking for. So you will subtract 105 on both sides of this equation. So this will become a 0. Then you have x is equal to 180 minus 105 is 75 degrees. So you conclude and say, therefore, angle AXB is equal to 75 degrees. Is equal to 75 degrees.